Hey, oh, I'm not even here. I've vanished. I'm gone. How you doing, Hannah? How you doing, Adam? Mubot is awake in the chat, so you can check points now. We're going to do a little bit of reviewing and all that great stuff. We got hit with a copyright claim on our 8-hour stream, and it wasn't Monstercat. It wasn't, what else? It wasn't The Rock coming after us. It was all those things. Mubot is awake. Can I show this? I don't know if I can, but yeah. So if anyone sees, if the 8-hour stream is monetized, I'm just going to show it. I don't know. I don't think YouTube can get mad. Does it have any personal information? I don't know. Here it is in the background. So this is the copyright claim we got hit by, copyright summary, but don't worry, it's fine. Random thing. And they literally play the portion where Tiny Brian is announcing the winner of the coot. You can't even see Tiny Brian. And so I'm like, great job.
Great job.
So it's like Tiny Brian announcing. This happens on YouTube. It's a bummer. Like, you can literally barely see Tiny Brian, and the portion of the claim, the portion of the video they're saying is in the 30 seconds where Tiny Brian is announcing the winner of the Kahoot, that they're saying they have the copyright to Tiny Brian's voice, and it's literally me announcing the podium. So I'm just like, you don't own my voice. I don't know what they did. I don't know how they found it, but they might just be searching for 8-hour streams. And that's the kind of nonsense you have to deal with. And then somebody put a review. Anyways, someone reviewed a wrong class for a teacher that they didn't like. And I'm like, oh, dealing with that. How are you doing? How's everyone else doing right here? Let's start doing some review. Oi, hoi, hoi, hoi. I'm going to sleep or get some food, or I don't know. I got these really great Izzy drinks. Izzy, great stuff right there. We're always advertising our products on here. Some Nosi yogurt, some Izzy drinks, all that great stuff right there. Good stuff. But how are you? I see Jens is here. I see Janie's here. Linda is here. What questions are there? We'll try to do a little bit of review. Chill out here for a bit. What questions are there? We could do some 201. Love the new video. I may have used it last year also. This is a good idea. Uda, good to see you here. Terry, good to see you too. What would you like to review or talk about? It's been a crazy day. Been trying to keep up with all the messages, so just flow of thought. Keeping up with everything. We're here to review and practice. That's the goal. We don't have 40s on our tests. Word problems. Let's do a word problem, Demetrius. Let's do this. Let's check it out. Demetrius says, can we start off with some word problems? That sounds great to me. A lot of random chapter. Why am I so zoomed in? What's going on? Okay. Serious face. So when we're doing getting ready with the format and what Nicole said. Yeah. So when we're doing, did I miss something Nicole said? Nicole said, what are the biggest conceptual things that we need to know for the exam? Definitely going through the practice tests and the videos. Exam 3 is just a big idea of like confidence intervals and testing, like confidence intervals and testing. Like, this is like the thing you need to know is there's more to the exam than this.
But wait,
there's more. When we talk about confidence intervals and we interpret confidence intervals, because we did this yesterday. If I were to make jump output, we still have some up here, and you were to look at this interval right here, we could do an easier one. Analyze distribution. You want, if you're at this point, then you're good. But if you're not, it's okay. First off, what is the third or fourth condition for analyzing and making a confidence interval to talk about what somebody spends on a pet? First question of the day is, what are the third and fourth condition, if there is a fourth, for what somebody spends when getting a pet to make a confidence interval? I'm removing the copyright strike. I'm removing that copyright strike. What are the third and fourth condition when making a confidence interval for what somebody spends on the pet? Thoughts on that? What are the third and fourth condition for what somebody would spend on a pet? And I might send out announcements to let me send out. We got 21 people here. I'll put up a thing on the, what are the third and maybe fourth and why? So we want to be able to walk through these things pretty much unprompted. I'm going to send out an announcement here. And say reviewing live on YouTube. Reviewing live on YouTube. Click here. Okay. So that way we can get a few more people in here. What are the third, and is there a fourth condition? Okay, reviewing live on YouTube. And there's that. Okay, cool. Okay. Nearly normal because it's quantitative. Exactly. Nearly normal because it's quantitative. That's exactly it. And so we kind of pass it here a little bit. It's ridiculously skewed, but the sample size is way more than 100. So nearly normal encompasses also the large enough n condition. Condition 1, we all know it. It's random. So condition 1 is no monster cat copyrights today. Condition 1 is randomization. Did we randomly select the observations here of individuals? Condition 2 is less than 10%. These 806 people need to be less than 10% of the population. And then we pause, do that pause in the chat. And then condition 3 is based on, is it quantitative or categorical? And since this is quantitative, we are going to do the nearly normal. Large enough n is for specifically for the sampling distributions. Nearly normal is a way to encompass it. So with all this right here, what are we going to interpret? Well, let's start by interpreting this interval. Now, I'm going to have you try to write it out. Remember, it's much better if you practice it, but ask those questions. We'll be answering as many questions as we can. How do we interpret this interval? How do we interpret this? So let's start. We were writing this out yesterday. I'm going to kind of help out. We'll do it in parts right here. Try to interpret it. You are right, Muhammad. Keep going with that. Keep going with that. I think interpretation stuff is good. I am blank % confident that the true blank is contained in the interval blank to blank. So I am blank % confident that the true blank is contained in the interval blank to blank. So what do we have right here? And great to see everyone here. Frankie and Mary and Jordan and Brianna. Great to see you all here. I am blank % confident is our first part of our confidence interval here. That the true something, and that's our second part right here, is contained in the interval blank to blank. You can think of it as 3 parts. The 3 things you really need to talk about. There are interpretations on the exam. We're going over that a lot yesterday. There are interpretations. Still up. Good to see you, Morgan. I am 95% confident that the true mean of pet expense is contained in the interval. Great job. Hannah just knocking it out of the park. 10 more points. We're still on smaller points today. Hannah, great answer right there. Zach, great to see you. I am 95% confident the true mean pet expense is contained in the interval. Demetrius, excellent work there too. Demetrius, great job. So check out what people are writing in the chat. The hardest part usually is the what are we talking about part. I am 95, and that comes from this right here, % confident that the true pet expense, or I should mean pet expense, is contained in the interval, and then 563. I'm going to round it to 747. Now in dollars, I'm going to throw some dollars for that context. But tell me, who can tell the margin of error of this interval? And pretty quickly, does anyone know the margin of error of this interval, and how could you find the margin of error? I'm going to do an estimate in my head. Okay, I've got a small estimate of the margin of error. So what is the margin of error of this interval, and how can you tell it? Peter can. Good to see you here, Peter. So what is the margin of error? So take a moment and be like, how could I get the margin of error? Kayla just destroying it. People showing the mathematics in the chat right now. And what you want to think of, what do you want to think of when you think the margin of error? Like, people are wondering, like, how are we getting this? How are we doing this? And Kayla just, amazing work, Kayla, just like, boom. What are we doing? And take a look at the mathematics, everyone. If you see the chat right now, you're seeing all the mathematics being performed. And what we're doing to get the margin of error is we're taking the upper minus the lower. That's how long the interval is. That's like how far these numbers are apart. These numbers are this far apart. And then as people are pointing out, all the Kaylas are pointing out, we're dividing it by 2. Define for me the margin of error. Like, we learn formulas, we learn these things right here. Define for me. The margin of error is what the length of the interval. So like, boom, Demetrius, great job. The margin of email. Thank you, Jalen, right there. Of course. Try to put announcements out everywhere. Just, I think all of our brains are fried. I don't teach Bio 1010. Not salty about that. Anyways, half the length of the interval. The margin of email. Well, think about this. What's really interesting about this? What are all the types of interpretations that we... I think we did that yesterday, Ashling. So definitely check out yesterday's morning review. We did a review yesterday morning where we did a lot of interpretations. We went through the different tests. We're kind of just doing some little bit of interpretations here. The general confidence interval interpretation is on the screen, and we did pretty much all the interpretations yesterday. I just watched your 2-hour stream at work and a little more confident. Like hearing that. Of course, Frankie, shout outs, man. Great to hear that. And I really want to just see everyone on campus and everyone say, hey, there's an office hours playlist. Every video is stored on the stream, so you can see them all later, whenever you like. And thank you so much. So much positivity. You guys help so much. Like, man, I know it's a lot. I know the world's on fire. How are you? No, like we're all there for each other, and I appreciate that. It's all about that positivity. So what if someone wanted to test the value of 500? How are you? What's up, Olivia? What if someone wanted to test the value of 500? Talk to me about testing this value of 500. Thank you, Matthew. What if someone wanted to test a value of 500? Like, talk to me about it. Kayla and everyone, you're always welcome here. So let's change the question right here and say, what if someone wanted to assume the true mean was 500? Now, the way this would look is we'd have to say, no, we don't want to do that. We'd have to say here, null hypothesis that mu, I'm going to insert that mu symbol. So where's my mu symbol at? Mu equals 500. That's 500. And the alternative, without any talking about it, the alternative is usually the two-sided alternative without any sort of like, where are we going with this? So it would be, yes, Hannah's known where I'm going with this question. Exactly. So Hannah sees the theory of what we're doing right here. We're using the interval to do a test. Exactly. So it's not inside of this interval. And we'd like, that is not a very probable value. We got to not say the other one. Kayla was here for the other discussion yesterday. We have enough evidence to reject the null. Exactly. And we'd be rejecting this null at the what level? Like if we run this test, which I will in a second, we will reject the null at this level. And you are correct, exactly. And the reason everyone's saying reject the null is because the value of 500, which is the null value, this value right here, is not contained in the interval. It's outside this interval right here. 500 would be lower than the lowest portion of the interval. It's outside the interval. So you're like, I don't think that's true. It's like, just put in an example that's outside of this. If I tell you, I think steak dinners cost about $20 to $30 at Chop House. And then if someone said, I think it costs $8, I'm like, that's not true. I don't believe that. That's outside my interval. And correct. And Demetrius and Megan are pointing it out. We can reject it at an alpha level that is basically complementary to this interval. Take a look right here. You can see the interval or the 95% confidence interval, and we can do 1 minus confidence level equals the alpha. There's the alpha right there. So the alpha is the rate at which we can reject on the two-tailed test. The form was sent out. Check for the form sent out. I don't have it here at the moment. Someone can post it if they want, if a mod posts it. But the two-tailed test. So let's run this. Now, when I run this, I want you to tell me, Brian, your p-value for the two-tailed test must be this. Before I hit run, remember where 500 is at, hint, it's somewhere down here. Before I run this, you would say, Brian, you're definitely going to have a p-value that's what? Good to see you, big boy. What is saying? Oh, no, we don't want to rock the worlds. Remember, the interpretations are not graded, so you won't see that portion of your grade yet. We definitely don't have a 40 average, though. It's going to be lower than 0.05. Oh, Muhammad's taking I like Muhammad's guess right there. I think Muhammad's probably right. Very close guess, Muhammad. Muhammad, that's worth a little extra points on top of that. It's a very low p-value because it's pretty far outside the interval. So Muhammad's like, that's pretty far outside the interval. I'm going to guess a very low p-value. And it is very low. You look at Muhammad's guess, and they're 10 thousandths off. So that's a good educated guess to say that's pretty far outside the interval. That's going to be a very low p-value because we're going to reject it. Now, we can do the different version of this where I say, what if we change the null hypothesis to 600? So let me make it easier. Okay, let's go 570. If I change the null hypothesis to 570, just go off the easiest portion of this. I think it's 47 questions. I think 47, somewhere around there. If I were to use the value of 570, then look at 570 and talk to me about that value here. I failed to recognize. Nice job, Cece. I actually have a cousin named Cece, or second cousin. So 570, and maybe I need to redraw my arrow now. 570 is what? Wow. 570 is what? So talk to me about this 570 and be like, well, 570 is contained in the interval. Now, just tell me what you know for certain about the p-value since it's now contained in the interval. we'll take a guess at it in a moment. But great to hear, John. Since 570 is contained in the interval, what would you then know for certain about this? And this is why we can know that we wouldn't do this. So since we're doing a 95% conf interval, it will be high. Keep going with that. I have no idea. It's going to be greater than 0.05. Exactly. It's going to be greater than 0.05. That's the big thing to know. Anyone got a guess at it? I will throw 100 points if someone can guess really close to it. So 570. Anyone got a guess? We're going to fail to reject the null because it's something we would believe it's in the interval. I wouldn't go that high, Mohammed. I wouldn't go that high. It's a good, decent guess. It is high. I wouldn't go that high. I'm going to say 0.07. I'm going to say 0.07. It's not going to be, if you notice, it's towards the edge of the interval. Does that make sense? It's towards the edge of the interval. So since it's towards the edge, it's like, well, it's going to be low, but not too low. Does that make sense? As I say that, like, it's towards the edge of the bottom of the interval. Like it's towards the edge, but it's not outside the interval. So I think Adam might have a better guess. People are guessing all around my guess now. Oh, see, look at that, some 0.068. Let's throw some points out, though. I'll throw some points out to everybody. Good guesses, but why is it a p-value above 0.05? This is the big concept. It's a p-value above 0.05 because it is, say it with me, 570 is a believable value, or a very probable value, we should say, because it is what? 570 is a very probable value, not rejected on the two-tailed test, because 570, Kayla, great job right there, is in the interval. Since it's contained in the interval, it's like, well, yeah, sure, that's probable. Can we say we are 95% confidence? So, Megan, the great question, Megan. 95% of 95% conf intervals will contain the truth 95% of the time. It's about the repeated process of making intervals. It's not that one interval has a 95% chance of containing the truth. The repeated process of making 95% conf intervals will lead to the result that 95% of 95% conf intervals will contain the truth. I like to say 95% of the time. A little redundant, but it's not about one interval containing the truth. It's about the long run law of large numbers from the second test, law of large numbers, where repeated intervals 95% of the time and 95% conf interval will contain the truth. We sometimes put that theory question on the test. That's a good, Megan, that's a good theory question right there. And I'm still confused on how we find the PO if we're not given a graph. We have to draw the T chart ourselves. Is there? So Jalen's asking about the P values. Now here's what we can do. A very classic type question, which is on the tests themselves, on the practice tests, is where we take something like this. Now pretend you hadn't seen that. Where we take something like this and let's insert. Okay, 2 seconds. I'm going to insert a shape right here. Okay, so we can actually block out every one of these values. You could get output like this and have to find every single one of these values. Where shall we start? Let's put numbers beside these, and I want people to maybe figure out how to solve any one of these and how they all relate. You can figure out every single one of these values right now. Well, 4 is already given, so we don't need that. What value do you want to talk about, or can you solve any of these? Now, if you rewind the stream, you can see them, but don't use that method. Pretend you can't see them. So, the test statistic. Good, the test statistic. Okay, so to find the test statistic, so we need to know one more thing. No, we do have the, okay, good. Test statistics can be the least fun. That's the least fun. Oof. Okay, Olivia asking a big question right there. Find the test statistic. Okay, so let's find the test statistic, which is probably the hardest one here to find. To find the test statistic, we have to use the following formula. T, which is the test statistic, which is a standardized unit of measurement that things are away, and great to see you, Petra, is equal to y bar minus mu naught s over square root of n. This is probably the hardest one to find on here, I'd say. So to find the test statistic, let me ask you first, what is y bar? Help me identify y bar on here. Who can identify? Just throw answers out there. Don't worry, this is practice. What is y bar? And the way it describes it here is a little bit weird. So people are doing a great job solving the other ones too. Good practice in the chat. I see a lot of right answers. So what is, hey, Tara, great to see you here. Great job. Who said that? I think Haley said that. This is the estimate, which comes from a sample. That is y bar. And remember, we're doing the estimated mean. So what was the mu naught? What is mu naught? Mu naught stands for hypothesized. Anytime you see a little naught there, that's hypothesized. So what is mu naught? Mu naught is what? So what is mu naught? It's hypothesized. So mu naught is 570. That's the hypothesized mean, what we hypothesize it to be. What is the standard deviation? Well, that's kind of obvious. It tells us that. So S stands for standard deviation. But now we're stuck. We don't have a sample size. Ooh, stuck. We're done. Time to go home. Class over. No more. Is that one? It might be around. No. Alexander to the rescue. Alexander and Muhammad, how did you get that? They are saying that the sample size is 806. How are you figuring that out? So, n equals to this, and thus degrees of freedom for the one sample t is n minus 1, and you could reverse it and remember that the sample size is n plus 1. This is a more difficult question. It requires a lot of mathematics. This is the harder thing to find in the output. So we are finding the test statistic, which is the standardized metric by how far the sample mean is away from the hypothesized mean, and people are finding there the sample size that was used. So at this point, it becomes just a plug the numbers in sort of game. And so we'll just circle and highlight. Sure, this is 806, and that's 806 right there. And so now we plug in 655.815, disappear off the screen, minus 570. And then over S over square root of n, 1333.03 over square root n, 806. And who has solved this out for us here? About 1.83? John, let's see how good you are. Ryan the Frog there, Kermit. Boop. There you go, John. Great job. Great job. He's riding the unicycle. I love that. This cracks me up every time I see it. Great job, John, right there. Excellent work. Everyone give shout outs. So that's probably the toughest one on here. I'll disappear so you can see it again. You just have to identify all the output and solve the equation because the test statistic is the t. We are literally solving this value right here is this. That's the t, which is this right here. But no, great job. And Kayla, thank you so much. Everyone giving shout outs. Good to see you, N8. Good to see you. So now we have the easier ones. I would say they're easier. They don't require as much work, hence easier. So now let's remember that probably the easiest of the p-values to find is going to be what? So we just did number 1. That was a longer solve. I think the easier, what do you think is the easier of the two? Yep, you can jump output. Yep. You do have to know how to read this and understand what it is. No, good question right there, Cece. I think people are answering what 2 and 3 are. And so great job. I think the easier of the two is going to be number 3. I think number 3, right? Because explain to me when you have a greater than alternative and you have a less than alternative. And so what do these need to equal up to? Like if you add those up, like if you add up the two values, it has to add up to what? So you have a greater than and a less than, they add up to 1. And you can kind of see this is the greater than alternative right here. It'd be this area. So you know it has to be something small. The less than is this very large area over here, which doesn't even shade because it's so large. It's not a small p-value, so it doesn't show it. So they equal to 1. So if you add these two right here, you will get 1. And let's go ahead and take a look at that. All we do is just show me the mathematics right now. Show me the mathematics. Who knows what we're going to do right here? There's a hint. So we can find the other one. It's funny, I used to guess at these things, and then I was like, oh, wait, you can algebra it. Yes, Kayla, great job right there. And there it is right there. And so that is the p-value right there, because whenever you solve it, what would you immediately do with those two p-values to double check your answer? You get this value and you get this value. If you were presented with a question like this, you get these two p-values and you say, well, let me do this immediately. I'd add them up and see if they add to 1. Great job. I think Olivia's got the next one. And then Nicole and everybody doing such a great job because the does not equals alternative is always what? So whenever you have a does not equals, so this is the does not equals alternative. So that's the does not equals. And it's always what? Here, I'll show you visually. The does not equals is this. Well, not that. Does not equals is those areas right there. It's always multiplying the smaller by 2. So you're just reflecting it on the other side. So people are showing the mathematics in the chat. The mathematics would be to take the smaller p-value, because p-values can only go up to 1, and then we multiply it by 2, and we get double the smallest p-value, and we have done it. we have solved out all of this output right here. And great work. That's excellent job. Who has another question for us to do? Really good review. We'll go for at least like 30, 40 more minutes. We'll try to go like an hour and a half tonight, something like that. I don't know. Got a lot of videos up, but don't want those crazy world we live in. Let's head over to the main screen. Put those questions in the chat. What do you want to hear about? Let's do this. Need more Izzy drinks. Good stuff. Izzy sparkling blackberry lemonade. Should be illegal. There will be a question like, I can't say there will be. Can we go back over beta real quick? We can do beta and power and all that good stuff here. Beta would be good. Well, let's do it. Like knowing p-values, we did a lot of things. I mean, there's hard concept on the exam. We do hard concept. Can we do something regarding type 1, 2 errors? Yeah. Yeah, we do some type 1, type 2, beta, all that good stuff. Let's go check out talking about power and errors. Let's do some power and errors right here. Here we go. Can't ride hoverboards on water. You need power. Back to the okay. So talking about power and errors. So when it comes to power, this is where, you know, we need to memorize some stuff. What time is the exam? We're actually talking about having it open pretty much all tomorrow, just for people's schedules, because it's already been fun. It's supposed to be like 6 to 8:45 tomorrow, and I have it set for those times, but we're talking about, Dr. Panel suggested, let's just have it open all day, so the instructors are communicating, and I'll be checking that out later. I think we have it open starting at 6, right? The period is 6:15, and then we have it open a little bit longer, but we're talking about... Yep, everything's posted afterwards, you bet. Are there any formulas not on the review sheet? Things like upper minus lower divided by 2, which is the margin of error. But nothing major. Nothing major is not posted on the review sheet. Yeah, I think so too. That's we really just want to be out there to kind of... We want things to be easy in this crazy, crazy world. And it makes it easier for us. We like that. Talking about power and margin of error and all that great stuff and errors right here. Okay. 47 questions or something like that. I don't know. Okay. Awesome. So with this right here, also hi. Hi, Rachel. When are grades due? I think something soon. All I know is I get grades done as quickly as I can. And I tell my graders that we want it done as quickly as we can too. I'm like, let's get this done. And some graders are a little bit slower than others. And they're taking finals too. So I just shout outs to my graders. So here we'll put a quick screen up so everyone knows we're going to start this in a second. But shout outs to my graders. They've been doing a great job all semester. And it's definitely a lot of work grading a couple hundred students' assignments. Big shout outs to them. Big thanks to them. I always want things done as quickly as possible and as correctly as possible. There have been errors. Please contact me if you think anything's been misgraded. Snaps for graders right there. I can't snap with that hand. I can snap with this hand, though. There you go. Some snaps for graders. But yeah, one of my classes... like week 1, Mackenzie, no. I'm always in constant communication with my graders. One of them said it might take through the weekend. I said that's okay. She communicated that to me, and we understand, and it's all about that communication. I say to them, if there's an issue, I stopped here. Which notification? I don't know which notification. I don't even know. I don't even know. Okay. Let's bring out all that positivity. We got this. Here we go. Let's talk about some power. Oh, wow. Okay. Oh, I'm sorry to hear that. Well, don't worry. We're here for that positivity. We got this. Okay. Whew. So, what we're going to do right here is talk about power to begin with. What makes up power? That's weird. What makes up power? Any ideas? Well, power is 1 minus beta. It is 1 minus beta, which beta is making a type 2 error. Well, confidence. Oh, like, go on Discord, message me. It's in the rank check channel. There's a rank check channel on Discord. So power, what makes up power? Well, like what 3 things? Let me make it easier. What 3 things control power. Control power. What 3 things control power? We like a few of them we can manipulate. Some people are effect size, sample size, alpha. Look at that. Great job. So alpha, effect size, sample size. So power, there is a direct definition of power. And we try to usually put the... If you see something, anything close to this, like when we put something false on the test, there's usually like a huge landmine on it or something where it just explodes. But power, let's put a definition of power. And let's talk about what it is. Definition of power. Definition of power, the ability to correctly reject the false null. Better way, this is not, you're not going to see this in any stats textbook or the test. This, what I'm about to say right here, and great job, Olivia, right there. What I'm about to say is not in a textbook or not on test. Power is the ability to find results when results exist. So when we find results in a test, what do? I just want you to think, if you say you found results, like, oh, I ran my test and we found like results. We found something. Usually what are we talking about? Once again, I would not, but I just want to make it make sense what we're talking about here. If you say I found something out important, you're talking about you did what? If you say, I found some big results with my test, what have you done? If you say like, oh, I found some big results, like some really crazy stuff with my tests, what do you think the person did? This would never be in a textbook or anything like that. It's the way I understand it. We have to have a way of understanding things beyond like textbook definitions. So if you say you found results, what would that mean? Someone's like, well, that's a way to find more results. So I ran my test, reject the null hypothesis. We rejected the null, right? So if I say I found results, I'm like, I rejected the null, I found results. I had evidence of something, right? You know what I should say? Well, yeah, to find the result. Yeah, find results. Because we're not going to find evidence. We're going to look at the evidence. So power is the ability to find results when results exist. So if we find results, we are rejecting the null. And since the results exist, the null is false. Does that make sense? If the results actually exist, if there's actually a difference right here, then the null hypothesis would be false. So we're rejecting the null when we should. So power is basically the ability for a test to find results. When you think about a test that is not powerful tests, let's say, is your ability in basketball different than a free throw? So I don't think this would be a powerful test for me. If I wanted to test to see if I'm a 30% free throw shooter, what is probably Brian telling you about his basketball abilities in here? So this, I don't think this would be a powerful test. And it's probably due to one of the 3 key concepts, and I'll review that right here. Exactly, because there's a high chance of a type 2 error. Trying to put this in a different context rather than just read through textbook definitions. Is your ability in basketball different than a free throw percentage of 30%? So what am I trying to tell you? That I don't think this would be a powerful test for me. Because I don't think we'd be able to find results right here. Like I couldn't figure out if I'm really different from 30% because probably why. I'm not good at basketball. That's a hint. So we say, let's go out and test to see if Brian is different than a 30% free throw shooter, which would look the following way. We'd write the null hypothesis as the null hypothesis that the true proportion of free throws Brian makes is 30%. The alternative hypothesis is the true proportion of free throws Brian makes is not 30%. And I'll give you a hint. How dare you, Alexander? Alexander's right that the effect size would be very small. And so what is Alexander trying to say by there's probably a small effect size here? If there's a small effect size, the difference between the null and the truth. So I want you to think about this. We're talking about the difference between the null and the truth is the effect size. The null hypothesis is that Brian is a 30% free throw shooter. So the truth is probably what to that? If the effect size is small, and it's going to be hard to see this, just talk to me about the effect size is the difference between the null and the truth. So the truth is probably what? Which is going to make it hard to see that if Brian is different than this. I'm telling you there's a small effect size here. It's probably because the truth is what? For Brian, the truth, which we can only estimate, it's probably what? So talk to me about my free throw abilities and why it'd be hard to see this because there's so small effect size here. The truth is that Brian's free throw percentage is probably close to 30%. So it's going to be hard to tell if I'm different from 30% because maybe I'm truthfully like a 28% free throw shooter, but it's going to be hard to see that. Does that make sense? I'm probably close to 30%, and thus there's a small effect size. If you wanted to see if I was one of the best people in the NBA, would it be easy to reject this null hypothesis? Once again, I'm not good at basketball. So now when you think about this would be a larger effect size. Now, we don't know what the truth is. Shaq and I would have a good competition on who's the worst. So at free throws, he'll beat me at everything else. Might have a shot at free throws though. Pun intended. Effect size, so it's a nebulous thing. It can be negative because it's just the difference. Like if there's a negative difference, we don't really know it. We only estimate it because we'd have to know the truth. Does that make sense, Olivia? I think that's the hard part about this is you don't know how good Brian is, but I'm just telling you, I'm a bad free throw shooter. So what does this mean right here? Brian throwing shade at Shaq right there. So now it's going to be easy to see right here, right? If you compare Brian to this and say, is the true proportion of free throws Brian make 98%, you'd be able to reject easier because it would be easier for us to see exactly because you're going to be able to tell really quickly that the truth is way far away from this. Now, you don't know what the truth is. You don't know. I'm just making these up. Like we're saying, I wonder if Brian can hit 98% of his free throws. That then becomes our what hypothesis. So great question right there. You just make up a number. You say, I wonder if Brian hits 98% of his free throws. That then becomes the what of your current belief that you could test. And this would be a more powerful test because it's going to be rejected pretty quickly. You're going to watch me for like a minute and be like, yeah, why'd I even think that for a moment? It'd be a very powerful test. The null hypothesis, and ranks on Discord points here. So you can hypothesize any value. That's just a hypothesize. Someone's like, I wonder if Brian makes 98% of his free throws, and that is the hypothesized value. So now that's going to be rejected pretty quickly. But we do run into some issues where Brian's probably closer to 30%. How could you figure out if Brian is 30% or not 30%? Because remember, Brian's pretty close to this. How could you do this? If the effect size is large, then power goes up. Does that make sense, Megan, right there? So if the effect size is large, it would be easier to reject the false null, which is power. If the effect size is large, it is easier to reject the false null, which is power. Power is the ability to reject the false null. If effect size is larger, power goes up. So if there's a large effect size, it'd be easy to reject the false null. No, Megan, great question. Thank you so much, Megan. So how could you, hey, Finch, great to see you here. Finch, I think previous semesters, right? So how could we then make this test more powerful, even though there's very small difference between Brian and a 30% free throw shooter? How could we increase the power of this test? Which the answer is there, over there. So how could we increase the power of this test? How would we make this test more powerful? Ideas on this. The sample size, yeah. Increase sample size increases power. It's how many observations do we take? Last but not least, we have alpha, which is type 1 error rate. And all of these increase, like every one of these, we'll put increasing any of these increases power because they decrease beta. So we could put this right here. So these are the three things right here. Increasing any of these increase power. Increasing any of these decrease beta. Beta and power are complements. Alpha and beta are not complements. Alpha and beta are not complements. So alpha is just how often you reject the null. Well, they're not invert. Oh, inversely related. Yes, Kayla, not Kayla. Olivia, great answer right there. Alpha and beta are inversely related. They're not complements. So 1 minus beta is power. 1 minus alpha is really not something we use. Like we don't do 1 minus alpha. So it's type 1 error rate. And so that's what power is. Power is the ability to basically find results. And if you watch Brian play basketball longer, alpha and beta are type 1 and type 2 error rates. They're just, great question, Tara. Thank you for asking. Alpha and beta are type 1 and type 2 error rate. So reducing alpha. Correct. Alexander is correct right there. They're inversely related to beta and they are directly correlated to power. So literally any of these go down right here to Alexander's question. If they go down, then beta would go up and power would go down. but it works the other way, that if they go up, beta goes down and power goes up, because power is the inverse of beta. Does that make sense right there, Alexander? So they are inversely related to beta, but they are positively related, like positively correlated to power. So you can say if your alpha goes down, your power goes down. If alpha goes down, your beta goes up. If effect size goes down, beta goes up, power goes down. So that's really great understanding right there of how the relationships work. It's just, but the final result is a positive relationship where they follow each other. The middle result right here is a inverse relationship. Yeah, we'll do tools and techniques next. You got it. Thank you so much. Yeah, I try to draw everything out. Hopefully that helps. So great question about there. What is alpha and beta? We have a really great way of talking about this with the following. It should be as accurate can be, because we put them in the grades and we put the numbers in. So it should be. You say that's so concerned, Brian. It should be. So here it is right here. 1, 2, AB. So Hale says the notes help. I hope this is the same. 1, 2, AB plus minus. So when you think about a type 1 error, say it in the chat, is related to your what that you pick. Now you pick this. Sherry, great to see you here. A type 1 error is related to your what that you pick. So this is why I say 1, 2, A, B plus minus. It's your alpha level. Just, you say 0.05 alpha. That means 5% of the time. Yeah, no, you got it. 5% of the time you're going to make a type 1 error. It's just how often you'll make a type 1 error and reject the null when you shouldn't. More on that in a moment. So your type 1 is your alpha rate. You pick your alpha. Now, beta, as we said, is made up of 3 components. Review back earlier if you didn't hear this part. We were just going over effect size. That's effect size right there. Alpha, that's the alpha right there for the A. And also your sample size. Beta is controlled by those 3 components, which are inversely related to beta. Any of those go up, beta goes down. So if these go up, beta goes down. So you don't want type 2 errors. So they're inversely related, but they're not complements. So when we look at this right here, what we want to think about is, what is a type 1 error? Now, I like to call it a false positive because, it's like a false alarm, literally. We did the fire alarm example last time. We'll do a different one. What would be a good null hypothesis? Like, what is a current belief you hold? Does anyone have a current belief? Let's talk about the cost of a type 1 error here coming up here. What is a current, never beta only? What is a current belief that you hold? What is a current belief that you hold? People are talking about what a type 1 error is. We reject the null when it's true. That is correct. So what is, like, we were talking about fires last time. Like there is a fire or something, or not a fire. So what do we have? Oh, that's your null hypothesis? Toddlers are evil. That's a good competition between right there. Dogs are better than cats. You know what you could do? Well, here's the thing. The null hypothesis should probably be Starbucks and Dunkin'. How do you spell Dunkin' Donuts? Dunkin' are the same. Or we could go real statistical. So we could go, watch this. We're even going to go bring in the real stats into this today. We're not going to go crazy examples. So we'll go mean Dunkin' ranking minus mean Starbucks rating. So what would this be? Who can tell me? Who knows? We've got the mean of the Starbucks rating versus the mean of the Dunkin' rating is what? Is equal to 0. We've just written out the null hypothesis. People are saying in the chat for the 2-sample t-test. And just think about how you would do this. Can you design... Not a 2-sample t-test. Can you design a test? Oh, I did -0. Could you design something right here where you went up to 100 of your friends and gave them a what? Now, you can't tell them what it is because you can't let them know. See, who was it who was saying Dunkin' is better? Cece, you're going to get a Dunkin' Donuts coffee from me. I'm not going to tell you it is that, though. I'm going to say, here's a free coffee. And I'm going to say, but I need you to rate it. So you're going to do a survey where you go up to 100 people and give them Dunkin' Donuts coffee. Sorry, Cece. And you're going to let them try it and say, give it a rating from 1 to 10. Then you're going to go up to 100 people and give them a Starbucks coffee and say, give it a rating 1 to 10. Now, probably the best null hypothesis is that there is no difference between the rating, as The Rock would say. It doesn't matter. He knows what's up. So there is no rating between the coffees, no rating difference between the coffees. So what we would get here is, let's think about what a type 1 error is. Now, we're not going into devastating results right here. The best alternative, before we get to our type 1, type 2 error, is probably the idea of there not being difference. Or let's say, now we'll do a difference of not equal to 0. That's fine. Everything's fine. Okay. So with this right here, let's very carefully talk about what a type 1 error is. Be very careful. Are you ready? In a type 1 error, just put a letter in the chat. The null is this. I want to see a letter. In a type 1 error, the null is this. I just want to see a letter. True. People are saying true. In a type 1, this is 1, error, the null is true. Great job, Nicholas. And so then if the null is true, what's going to be the error? And let's mark that on our sheet right now. So we're saying the null is true, but we're going to come in here and do what to it? Just think about if we're making, so the null is true. There is no difference. That's a true statement. There really is no difference between these. But we reject it. We're like, I don't believe that. I have evidence against it. Because we're going to make an error. You say, well, why would you reject it if the null is true? It's just that we're making an error. Hence, we're making a type 1 error. So in a type 1 error, there's the one, the null is true, but we reject it. So what does this mean? Just tell me the context of it now. What does that mean to say the null was true? So just think whatever the null says, it's a true statement. That is the truth. But we have rejected that truth and say we have evidence for alternative. Yes, Olivia said so perfectly. It is true that Dunkin' and Starbucks have no difference in rating. Like people just, hey, it's just coffee. But we think we have evidence of a difference. We reject and say, no, there really is a difference here, but there's not. It's not a difference. There is no difference. That is the null, which is true. So it is true that there is no difference in coffees, but we have said that there is, and we are wrong. That's the big thing. Make sure people know it's clear what the truth is, and then make sure people also know clear what you have decided. I have decided that there is a difference in coffees, but the truth is that there's not. But in a type 2 error, the null is what? So here's the type 2, and give me that letter in the chat. In a type 2 error, the null is what? What letter am I making right here? False. Hassan knows. In type 2 error, the null is false. And then we what it? You got to do the second F of the type 2. In a type 2 error, the null is false, and we blah, blah, blah. Type 2 error, the null is false, and we fail to reject it. F in the chat, even Mubot knows that one. So, I pretend Starbucks is better. I like that right there. And we fail to reject it. So when you fail to reject the false null, so let's put here, this is a false statement. So if that's a false statement, what is the truth? Here, Joshua, I'm going to remove that. Don't worry. Wait 2 seconds. Can I remove it? Oh, you removed it. Joshua, if you chat again, I think you just put it in the wrong chat. You can always retract things on here. We are some things. I think, yeah, Olivia's saying it. We are saying there is a difference, but there is no true difference. So there is a difference. Yes, exactly. So we believe that there is no difference. The null is false, but we fail to reject it. So when we say we fail to reject the null, we continue to believe that there is no difference. I'm going to not reject this. Does that make sense? But the null is false. So actually the true statement, don't do the truth, and so Kayla sees right there, the truth is there is a difference. We have failed to find that difference. And maybe it's because we shouldn't have talked to 200 friends. We should have done what? I.e. made the test more powerful. Maybe it's that we shouldn't have talked to 200 friends and given them free coffee. That's the argument for this. Maybe we shouldn't have talked to 200 friends. We should have done what? Talked to, I think I saw it there for a second. Talked to 400, was it? Talked to 400, 500, something. Increasing, larger sample means more power. So if we had talked to more friends, we'd have a more powerful test and a better ability to find a difference if a difference does exist. Or maybe it's just that Dunkin' and Starbucks are pretty close in how good of coffee they are. So I'm telling you there's a very small what. Like maybe there is a very small difference, which is probably what's going on right here. So I'm trying to talk to you about the what right now to say, well, if there is a difference, it's probably pretty small between these two types of coffees. I'm talking to you about the what right now. What am I talking to you over here about? When I'm just like, well, there probably is some sort of difference, but it's probably too small for us to detect. Like when we made this type 2 error right here, we didn't find the difference, but if there is one, it's probably pretty small. I'm talking to you about the what theoretically right here. The effect size. Yep. The effect, which there's going to be random, or there might be too much variation. That's another talk for another day. Like the variation in how people rate the coffee could also affect it. But the effect size right there, and also the distributions are going to be interesting stuff. But if there is like a difference, it might be very small, and the effect size is the true difference right here. Could be lurking variables. Someone might have saw me going to Starbucks. You never know. There could be lurking variables. Did we do a good experiment? That's great questions. If effect size is large, you get more power. Larger power, and we don't really manipulate effect size. The only one we really should control over is what? There's two we can control. There's two we can directly manipulate. One kind of depends on money. Which of these two do we directly manipulate? Sample's one of them. And then also, what's the other one we can directly manipulate? Which, not really good. Alpha. Because you can pick your alpha. And so the sample size is really the one you want to manipulate right there. The sample size is, if you have time and money, that's what it depends on. But you don't want to be manipulating alpha to say, let's just increase alpha and get more power. No, it's not a good idea. Not a good idea. Let's do some tools and techniques. Woo! Let's head over here. Madison, great to see you. Kayla, great to see you. Cece, great to see you. Zachary, great to see you. How many people we got watching right now? Mubot, tell me. Tell me in your brain of brains, Mubot. 82. What? Smash that like button. 77. Can we get 77 likes? Oh, you got it. It's just practice. It's just practice. Thank you so much, Autumn and Ethan right there, and Kayla and Tara and Finch and CC. JK, 79 now. JK. We got this. It just comes down to practice. Just comes down to practice. Let's practice some tools and techniques. 32 likes. Thank you so much. Let's try out some points again. Hopping over to the main screen. Tools and techniques. Wrong button. A copyright claim. Whatever. Whatever. Tools and techniques. That's how you spell it. Good. Okay. Woo. Okay. What's I saying? Wow, Emma, nice job on those points. It should. I'm 99%. Let me go. 2 seconds. Let me see if there's an email. Let me go look at it. We were talking about it. Did anyone? People are saying they're fine with it. I'm fine with this. Are we going to post an announcement? I don't have a problem with this. Let me ask. I am good. Is it a go? And should we change the times and announce this to everyone? Okay. All right. I literally, I'll show you the email. I said, I am good. Should we change the times and announce it? And I go, Brand, Steven's right here. There's my reply. I am good. Should we change the times and announce it? Oh, you can't see it. That's I am good. Should we change the times announcement? So hopefully we'll have some word out. But we and one of the great things is we always work as a team. So big shout outs to all the people I work with. But yeah, I'm good with it too. Good, CC. That's awesome. I'm pretty certain this will happen. Everyone seems good with it. It's all instructors have weighed in. Everyone seems fine with it. I don't think there's any complaints. We got like one class got 2 points, one class got 1 point. I'm sorry. It's totally, I am good. Should change. Opening it. Yes. Oh, thank you so much. Yeah, of course. I'm not. I figure I'll show my emails. Like, not literally my emails, but that's what I said to them. So, yeah. I want you guys to know what I'm saying, and yeah, it's cool. Free 100, like, no. We're talking about having the exam open longer tomorrow, just some more time. Yeah, more time for the Stat 1 exam, just to open a bigger window up so people can... Because let me just tell you, there's so many problems that can happen. Oh, thank you. Yeah, I worked on that a bit. I photoshopped it all. That's and thank you to the person who did the photography on that. It was really nice. For the Chancellor's thing, they did that for me. Really, really nice. It was really cool. We went over to like one of the buildings near Grieve, and they're like, psh, psh, psh. Really cool. Okay, tools and techniques. Question 1. Let's do first here graphics. I don't know how I spell graphics. I don't know. Graphics, we want to analyze. Listening for problems. I don't think I don't think so. Might be. I don't know. I'm like being honest. I don't know. It's just been everything's been crazy. End of semester usually is like a lot of traffic and stuff, like web traffic and stuff. Could be. Pellissippi State, yeah. Yeah, I think so. That's great to hear, Sherry. Great to help out with this. Winter Lines, people's favorite ice cream by the state they were born in. We want to analyze someone's grade on the test. We'll do 5 each. I don't know how to spell any. What are you doing to me? Okay. 2 more. I just want ice cream. Okay. Here we go. Great answers already in the chat. So how do you handle these questions? Like, let's just talk for a moment about how to handle these questions, which people are doing some great answers on the chat right there. And thank you, Kayla, and everyone announcing the points. So to handle these questions, to solve, identify the variable types for X and Y if both exist. You might just be doing a univariate graphic. Variable type for X and Y, bivariate, or Y univariate. So you want to identify what kind of variables we got. So let's do some highlighting right here. We've got ice cream and state you were born in, and great job. I think people are doing a ton of great answers right here. So if we're doing ice cream flavor and state you were born in, what do we have right here? People's favorite ice cream flavor is what kind of variable? And great job answers in the chat. Could be, you never know. We don't have a 40 average, no matter what any website says. Never had that. Yeah, Demetrius, great job. So what I'm doing is I'm going to highlight with different colors as we go through these. So the yellow right here is meant to be categorical. Does that make sense? So since this is 2 categorical variables, so now we would do mosaic plot or contingency table. There are other answers. I don't love them, like stacked bar charts, side-by-side pie charts. We don't do that. And do pause on this screen right here if you need. These are all the answers to these questions that can exist. The more you can draw these graphics and have seen them, the more it helps. But you notice we are in the mosaic plot contingency table right here, which is categorical Y or categorical X that way and categorical Y this way. So we are in the bivariate categorical section, which if I appear, I am covering it. No ring charts. No ring charts. Bad. I'm just kidding. Oh, let's head back here. So logistic. Yeah. So you see that now with the categorical Y, right? Some 320. And so, which we have crossed out because we won't do it in this class. So we want to analyze someone's grade. And so let's go here to grade. So what is grade? Let's do a different color right here to identify it as a different variable type. And hours they studied. So what's going on right here? What is this? Nice job, Taylor knows what to do. So 2 quantitative variables. And so now we would think QQ straight enough. No outliers. Easy with those stacked bar charts. QQ straight enough. No outliers. Plot doesn't thicken. So I think people might have said it earlier. What is this one again right here? There's a few, well, one graphic really. It is regression, correct. And scatter plot. Yeah, you know it. It's a scatter plot. Or time plot, but this one's not time oriented. So let's not put time plot because it's not time oriented. So the technique will be linear regression when we do the technique for this. And then down here for the next one. So if you look, we want to analyze grades. So I'm highlighting the variables right here. What do you notice about this that's a little bit different for grades previous to the previous one? I know, right? These are the tools and techniques. Just ask you like which graphic we're using. It's kind of it's not very usually just multiple choice. It's quantitative and you are right. So this is quantitative. Great answers right there on the graphic. And what's the difference between this and the previous ones? And Demetrius says it right there. Great job, Demetrius and everyone. It's univariate quantitative. So this is 1 quantitative. And probably your best options are going to be like histogram, a box plot, dot plot, stem and leaf. So there we go right there. So those are your good options on that one. And then next we have ice cream flavor. Ice cream. So what's the deal with that one? Little color coding hints for these as we go through. So what's the deal with ice cream flavor? So ice cream flavor is exactly one categorical. And with it being one categorical, we would have here bar chart, pie chart, ring chart. No, Kayla. How dare I? Don't do that ring chart. No. How can you remember bar or pie earlier? Go-tos on this, I would say. How can you remember bar or pie? Just remember the good old joke. You can make a pie chart of your favorite bars. You can make a bar chart of your favorite pies. And both those are categorical questions. Like, what's your favorite pie? Oreo, man. Oreo pies. Oreo pudding pies. Ooh. Apple pie. What pie is not? Is all good stuff with the holidays coming up. Just enjoy a little bit within moderation. Have a good time. The wordy dirty. And so next we have here... so this one right here, what do you notice right here? It'll be a trick question on the next one. Huh? Oh, I miss bars. Oh, like going out, right? Or something like that. So what do you notice about this one? Child pie. Oh, child pie greater than all. Good stuff right there. There is no moderation. Yeah, tell me that as I'm eating like a whole thing of Oreos. I've lost my moderation too. Yes, people are pointing out that this right here, grade is going to be quantitative, and ice cream flavor is going to be categorical. It's like, what is your favorite ice cream flavor? How much grade did you get? And so this right here is going to be what? So we have quant y and cat x. And so we generally put it this way. It'd be weird if we displayed other ways. And kind of, Demetrius, we'd have to do like chocolate versus vanilla or chocolate versus strawberry. That will be the technique, but it's a bit of a trick question. Sherry might know the right answer to the trick question. We don't put trick questions on the test. Like, I can do a trick question on this one, but I don't want to. We'll put here, you don't only have to allow 2. What is the graphic for this? Yeah, the by, yeah, y by x. CC, great job. I didn't even realize I did that. Yeah, statistics must be out all over my brain. Side by side box plots, correct. Side by side box plots. Or stacked histograms. It's basically multiple quantitative displays. So you're basically breaking it apart into multiple groups. You're making multiple box plots. So you have like a box plot for the GPA or the grade of people who like chocolate versus the box plot for the people who like vanilla. So you're just breaking it apart into multiple groups. Now, when we go over here and change this, let's change it from graphics to test/interval being used. So now we're just changing this. You know what we'll do? We'll copy this. And we'll go here. Now, we already answered what these things are, but now it gets a little bit more difficult. We have to think about what kind of tools or tests would be used. And so now we're going right here. Yeah, let me go back. Cece, thank you for asking that. Let me undo what I did right here. Is it Control Y in here? Stacked histograms. Okay, there you go, CC. There are tools and techniques questions on the test. There are tools and techniques questions on the test. Okay. So now we have on the exam will be clear. Yeah, it should be clear. It's like multiple choice usually. I think they're pretty clear. Like, I think they're pretty clear what the variables are and what we're doing. And now we're doing like the test or interval. I like to do it this way because multiple choice can kind of narrow down the options. So I like to see if we can get it without the multiple choice. Got it. Great job, CC, right there. So what I want you to think, since you have 2 categorical variables, there's a condition related to this. This is probably one of the easier ones where I was like, yes, 2 categorical variables. Mackenzie, you got this. Everyone give Mackenzie we'll throw some points. Mackenzie, you got this. Nice job, Muhammad, right there. This is the chi-squared test of independence. That is the chi-squared test of independence. And, oh man, love the positivity in the chat. So what's the condition since there's 2 categorical variables? Good way to remember this too, since we have, how is the test divided up between the response? I think it says it in the instructions. It's like there's true, false, multiple choice, numeric entry, interpretations, pretty evenly spread. So count data. There is the expected cell counts, but the count data condition is explicitly both variables are categorical. So, but there is also the count data condition, which I generally call the third condition. So count data means we have two categorical variables. Expected cell count is we want at least 5 expected cell counts for each group. How about the next one right here, which people were saying just a moment ago, where we're analyzing people's grades by how many hours they studied. So when we analyze, great job right there with the conditions in the chat. That's exactly right, Sherry. When we analyze someone's grade with how many hours they studied, this is a throwback to earlier tests. Oh no, it's the fourth. Random 10%, expected cell count, and then count data. There's 4. Sometimes they break apart the images. So much, Colin. We're throwing 100 points for Colin appearing in the chat. Thank you, Colin from Disney right there. So great. I love that. I love hearing good news that people got hired at like Disney and stuff. Such amazing news. That's awesome. And this is regression. What's another thing it could be? What is another thing it could be? It could be regression or also something else that has the condition of QQ. Colin or oh, Colin bringing so much positivity right here. Pearson sometimes breaks apart the randomization to independence. Colin, I just love it. He worked towards that dream the whole time, and I'm just proud of him. Oh, Colin's making me feel smile over here. Correlation. Colin swings by to give everyone some positive collination. Oh man, has anyone? I don't know. I won't say it. Colin, I miss seeing him at UT. I miss seeing him. He was on one of the signs, and I miss seeing Colin in person. Miss seeing him swing by my office. I miss all that. It's good times. Oh, you're gonna go Disney? That's awesome. We want to analyze grades on a test. What do you notice for one quantitative variable? Now, when you think quantitative, you think what? When you think quantitative, you think who? People are having so much fun right now. When you think mean. When you think mean, you think who? So when you think quantitative, you think mean. The A team, Mr. T, right? Because it's mean if you're doing some drugs. So, I'll throw another 100 points. Thank you, everyone, making Colin smile and making us smile. We're here for that positivity. That's what we do. So Mr. T is mean. So this is a one sample T, whatever. Do you want to do the test or do the interval? They're both basically the same thing. Why is it the one sample T? Mr. T is mean if you're doing drugs. He's a super nice guy otherwise. But it's quantitative, so it's means. Now, down here at the bottom, let's be careful. Don't do drugs. Drugs are bad, okay? So, only comparing 2 ice cream flavors. Only comparing 2 ice cream flavors. Matthew knowing our new quotes of the week right here. You might not know, but we also have jokes in our chat. All the great stuff. So, people know all their quotes. Love it, love it. Not today, my Pearson. I haven't seen that in a while. My Pearson's always wrecking everything for us. Sorry, my Pearson. What are the 2 flavors in question? Well, so we would have to pick 2 flavors. We could just compare the grades of people based on 2 different flavors, like Rocky Road versus Cotton Candy. I'll eat both of those right now. Just mix them together, get a little Rocky Cotton Candy. Awesome. Maybe. So we jump down here, but I want you to notice when you mint chip Rocky Road. So when you do this right here, I'm gonna try to focus. When you have this right here, you have a category of what ice cream flavor is someone eating. Oh, I'm sorry, Mackenzie. And that is what's breaking it apart into 2 groups. What would we be comparing between people's favorite ice cream flavors? Alexander, I'm throwing 100 points. Alexander knows what's up. How could, what are we going to compare between the ice cream flavors? We're going to look at the ice cream flavors and compare their whats. You are correct, grades and the what of the grades. So that's why it will be this again, but we're going to add another word. We're going to compare their grades, but the what of their grades. That is correct. We're going to look at the grades, and then we need an aggregate. We're going to look at the means. So it's once again Mr. T, but there's how many ice cream flavors? Right here, let's highlight this, and we're not just doing, we don't highlight in that color. We're doing 2 ice cream flavors. So we are doing the 2 sample T test. 2 sample T, whatever. 2 sample T. Cece's trying to focus too. Because when you analyze grades, grades is quantitative, and you could compare the means of the 2 groups. Like, of course, cotton candy is going to have the highest average of the 2, whatever we compare it to, because it's cotton candy. Good stuff right there. And one categorical, love it. One categorical right here is when we have what kind of test we're doing. So you would look at the ice cream flavors people like. It could be something like political views, which we did last time, still open. And you'd be comparing the what of political views. Kind of not prob, but or something like that. We did political views. It's not quite normal, but because it's categorical. You call it a Z-test. More, and we call it the proportion. I'd add a proportion. It does use the Z test statistic. So sometimes we'll call it a 1 prop Z test or Z interval, 1 prop Z. The Z is the statistic being used when you calculate it. Probably the key word right there is prop for proportion. So we want to look at the proportion of people who like a certain ice cream flavor. And we're not analyzing a Y variable here for proportions. We're analyzing a quantitative variable, hence the T. Great stuff. Excellent work. Let's go for an hour 30 tonight. What other questions are there? Put on some music. What are you thinking? What is going through your mind right now? Do you know? Are you ready for the exam? Are any of us ready? True, false? Need one. If you're an adult, your decisions. Need sleep. Get sleep. Get sleep. I'll get sleep too. Show the doc in, of course. Let me go show the doc, do a full zoom out for you. I'll throw even one more on here. Let's go back to the screen. Are we ever really ready? Okay. We want to analyze why people purchase from Amazon. Purchase from Amazon is a categorical variable. Do you make a purchase, yes or no? Thank you, grammar. Purchase from Amazon is a categorical variable, but there's a little bit of weirdness in here. Who knows this one? Throwing a curveball at the end. I have no idea what I did. What do we got for this one? That's a tricky one. What do we got? Thank you, Matthew. Good job. Don't worry. I promise you it's not. It's all about... I'll tell you this much. If you make a B, B+, A-, that's going to impact your life less than if you see an employer in the Haslam College of Business and you walk up and talk to them. That'll make more of an impact on your life, talking to an employer, going out there, putting yourself out there. So just remember that this test is not going to define you. A B+ in this class won't define you, and you should be proud. This is not the easiest of classes. If you make a B+, A-, I want you to be proud and be like, yes! Sherry knows it. Sherry got it. Great job, Sherry, right here. So the decision tree is, we should put here 1 Y, and then lots of X's. Really doesn't matter. Rock knows. It doesn't matter. It doesn't matter what the X's are. They're a bunch of quantitative categorical X's. Kayla, great. Oh, Kayla, that's so awesome. I hope to tell me how it goes. Kayla, congrats. I know Josh, man. Josh. Let's throw some points Josh's way right here. Josh, man, we feel you, man. You got it. And thanks for sharing that, Josh. I appreciate that. Treat yourself well. Get some good sleep. Relax. And we're almost done. You got this, Josh. Kayla's right there. Like, don't worry. I appreciate you telling me, man. It's... I was talking to my fiance and I was like, it's been a crazy last 3 days. She's on a trip right now. So, I think people said some true false. Okay, let's head back over here and share our win. Yeah, let's share our win. What is my win? I had a really good talk with, does anyone know Eric Kelly from finance, I think? Has anyone had Dr. Eric Kelly? Super, super nice guy and really doing a lot of great things. And we're planning to help some people in the Haslam College of Business with the grant I got. Great job on that 100 on the economics test right there. 100 on accounting. Great job too right there. That's awesome. True, false. Let's go check it out. But shout outs to my amazing faculty, and we're doing some great stuff. 94 on chem. Nice job. You know what you can share? 100 extra points in the chat. Let's go back to the main screen. All right, so no, we need good peel. We need just good times in life. That's what we try to do. Good times. Pass my physics class. Oh, nice job, Matthew. I love all the positivity. And we're here for the positive. We're here for the negative. We're here to help each other through the negative and bring that positivity that gets us through the negative. So thank you so much right there for that's what we do right here. And it's okay to share those things that bring you down, and then we're here to bring you up. So let's go check out the main screen. Here we go. Chem is tough, yeah. Mint in that chat, you bet. Okay, true, false, true, false, true, false. Can anyone try to come up with some true falses while I'm doing this? Who has true falses? Because I've been doing a lot of these, so I'm like getting burnt out. Like, I can't think of anyone. I'm not like, I'm burnt out. But like, I'm trying to think up more, and I'm like, okay, what have I not asked true false wise? Put some true falses in the chat if you want, and I might take them. Who knows? I probably will. Okay, question 1. Let's see right here. Precision of a confidence interval is how tight the interval feels. If the chi-square is large, p-value is 1. The larger the chi-square test statistic, the smaller the p-value. A t of 0 will have a p-value of for the greater than test. A larger alpha. Thank you so much. Great questions right here. How many can we get done? And we good fill in the blank. So good answers right there. If the p-value is small, it is only yeah. When the p-value is small, this means the null is not true. I kind of worked with that a little bit right there. That's good stuff right there. I'm trying to think of ones I haven't asked lately. I'm just thinking which chapters we haven't talked about tonight. Which chapters have we not talked about? We need 3 or 4 more. A little show music here. We'll do this. Let me look at my flashcards. Nice job, Olivia, right there. Trying to think of new ones I didn't do yesterday. Ooh. Like that. Good review from earlier. And here's the points for Matthew. 2 more. Definitely some wacky Wednesdays while we think up some new questions. Brian loves ring charts. What? In a 2 sample T, the n values. Oh, yeah, it's from the Canvas content, right? Aw, Lauren, thank you so much. It's not the easiest of classes, but Swing by anytime. Swing by anytime. Yeah, Olivia, that's a great way to go. Just the Canvas content have question bank tests on it. Oh, thank you so much, Sherry, right there. That's our goal. I want it to be educational and fun. There's the 11th bonus right there. That's, we're here to learn, and we're here to have a good time. Because I mean, you don't want to be somewhere where you're like, I don't want to be here. Why would you want that? Who would want that? No one want that. Precision, I think is how you spell it, of a confidence interval is how tight the interval is. Well, let's just think about what the word precise means. If someone says, I'll be to your house between 2 p.m. and 10 p.m. Say, I'll show up between 2 p.m. and 10 p.m. You don't want them to show up. You say, I'd prefer you to be a little more precise. What are you asking them to do? Say, show up between 2 and 10 p.m. Is your cable guy here? Is this Brian Stevens? I'll be to your house between 2 and 10 tonight. And I say, excuse me, cable guy. Can you be more precise? Can you make the interval wider? That's Sherry. Thank you so much. A lot of people told me that. That's the goal of this. Someone told me about their nursing. If you're in here and thank you so much for that email. That really made my day. Someone said I'm a nursing major. I'm not here to change anybody's major. If anyone wants to do stats or business analytics, I'm always about that. But if you find that this class helps you with what you're learning, that's what I want. I want it to be that this helps you with whatever you're doing. And I just want you to be happy with what you're doing. And if you like stats and business analytics, I'll talk to you about that all the day long. But if you love doing nursing, if you love doing what you're doing, keep doing it. And I hope this helps you with what you do. And so you'd say, can you be more precise? Can you be more precise right here? It's like, can Mr. Mob Boss working for the cable company, can you narrow down those values? So what would make an interval more precise? That's awesome. Business administration, that's awesome. I love everything that has a college of business. I love. So a lot of great options. What would make an interval more precise? So this is a true statement. What would make an interval more precise? Intervals, let's put answers right here. More precise. Sure. So smaller margin of error. That's a direct way. Decrease confidence. So actually decrease confidence. Because when you go from like 68, 95, 99.7, that'll make it wider. Does that make sense, Olivia? Like 68, 95, 99.7. It's getting less precise, but it's getting more confident, which those are inversely related. Does that make sense, Olivia? It's right there. And then there's one other thing I would mention also here, which is directly related to margin of error. Reverse it. Yeah. And so, Matthew, you're on the right track. If we want to be more precise, like you would take a what? Just think as a scientist, if you want to be more precise, you would do what to your sample? So don't worry about the mathematics. Just think, I'm a scientist. I'm going to go get a sample. I would increase my sample size. Now, we could show the mathematics on this, which I will show in a second. Increase sample size. And if you want to say less precise, everything here would be reversed. The formulas on this mathematically is one of them is the y bar plus or minus the t star with n minus 1 degrees of freedom, s over square root of n. The square root of n right here is in the margin of error, and if this n gets larger, the whole thing gets smaller. Does that make sense? Just visually. So the idea of it is if you get a larger sample, you'd make a more precise interval. Exactly. More data is a more precise interval. And mathematically, it's going to make n larger, and n is in the denominator. Square root, it doesn't matter. It's still just in the denominator. So since we have n getting larger, the standard error, which is this component, will get smaller. The standard error gets multiplied by the t mathematically. The t is also the part of the confidence right here. So the t, we would need to decrease the t, but the n is inversely related. So you can kind of see a lot of this right here. And so there it is. This is about as best I can show you. The margin of error is going to control the precision. Oh, that's all right, Farm Patty. But this is the color coding to everything right here in one of the confidence intervals with the margin of error, everything in the shaded region right there, the sample size being part of the standard error, and the t statistic, which controls the confidence. So, it's all right. Everyone's happy to see everybody. We're all here for that positivity. We're all part of Stat Nation right here. The larger the value of the chi-squared test statistics, the smaller the value of the p-value. True or false? What do you think? If we have a large chi-squared test statistic, and I think Olivia was helping us by throwing us some literal Canvas content questions. 100 points, Olivia, right here. I think using Olivia's flashcards, we're probably doing Canvas content questions, it sounds like to me. This is very, very true. So what is the smallest chi-squared possible? Now, remember, the chi-squared is the sum of all the observed minus the expecteds squared over expecteds, like the Pearson chi-squared test statistic. So when you square numbers, they have to be positive. What is the smallest value of chi-squared possible? Because you're going to sum up all these values, and they all have to be positive. They don't have to be big. But the smallest possible value of cell chi-squareds right here would be what? Like, the graphic would look something like this then. If they were very small, it would look like that. Close. Blake, great answer right there. I'm throwing a little more points. I'm throwing smaller points. The smallest chi-squared, cell chi-squareds is 0. And if you sum up a bunch of zeros, you get what? If you sum up a bunch of zeros, what would you get? 0 plus 0 plus 0 plus 0. Like, all of these would add up be 0, no discrepancy. So then you'd get 0. And when you do the test right here, when you do the chi-squared test and you draw the distribution, how many degrees of freedom does this chi-squared have? Just a quick glance at my graphic. Look at this right here, and how many degrees of freedom would this test have? Really good, quick. No, CC, don't worry. Great job. So now this has how many degrees of freedom? Be very careful. How many degrees of freedom? It has 1. Why is it 1? Because right now there's 2 groups here, 2 groups here, 2 by 2, 1 times 1, drop by 1, 2 by 2, 1 times 1, 1 degree of freedom. The chi-squared with 1 degree of freedom actually looks very right skew. That's what it looks like. And so literally I would go right here. I'll show you it visually. And I would plot chi-squared equals to 0 because there's no discrepancy. And who knows what the p-value here would be. That's the value of the p-value. There is no discrepancy. So what is the p-value here? Because I'm shading to the right of it, and I'm at 0, and I'm graphing all the curve to the right side. So we actually just ran the result right here. The p-value is equal to what? And I'll show it right here. The p-value is equal to what? Because I'm shading the entire curve to the right on a chi-squared with 1. And the p-value, did anyone say it? The p-value is equal to 1. Does that make sense? I think Alexander, great job. The p-value is equal to 1. Because this is the most likely result. If the two variables are independent of each other, what would the rock say about, like, let's say this is like you're studying. And so we have here, did you study? Yes or no? And did you pass or fail the exam? And this is what you would not want to see. What would the rock say? He would say it doesn't matter. Doesn't matter if you study, yes or no. Passing and failing is not related to it. It's independent. So in this instance, you would not have evidence for the alternative that passing the test is related to studying. But what we would want to see in these is a larger discrepancy here. Now, there is a discrepancy which would be calculated by those cell chi-squareds. Wait, we want to go over here. Wait, passing, failing. Okay. Make it look more like reality. There we go. Did you study for the exam? We're not actually calculating these values. That's value right there, CC. We're not actually calculating the cell discrepancies, but you would expect these cell discrepancies right here between the observed and the expecteds here to be what now? Just go with me with what this is. You'd expect the cell discrepancies, which when we add them up is going to be the chi-squared test statistic over here. You'd expect this whole thing to be water. You'd expect this whole thing to be water now. So now there's large... You'd expect these, they look at, not like expect, but mathematically they will be water now. They are water now. They are much, 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 much this. They're much larger. The chi-squareds are much larger. So the chi-squared is larger. We're making this up. These are not real numbers. The chi-squared is larger. So what happened to this value over here? I'll circle it. This value is now water. So wait, the chi-squared just got... There's a bigger discrepancy right now, right? Does that make sense? So pause me if you need it. Like, ask questions. The discrepancies got bigger, which are measured by this. Like, we would mathematically solve this. And there's more discrepancies. And that makes the chi-squared bigger. So since the chi-squared is bigger, the p-value got smaller. That's why this is a true statement. And this is all just theoretical right here. We're just coming up with a fake chi-squared value. But does this make sense, everyone? That we have more discrepancies. So when we mathematically solve this, it'll be bigger numbers. So we hypothetically could get something like this. And now the p-value is the area to the right. And because the chi-squared test statistic down here is larger, the p-value is smaller. They are inversely related. Like if you want a quick note on this, chi-squared is inversely related to p-value. That's about the quickest, smallest summary of it. We try to learn at different levels. But so write this in the chat. I'm going to throw 100 points. Chi-squared is inversely related to p-value. That's probably a good just memorization thing. Chi-squared is inversely related to p-value. Chi-squared up, p-value down. Chi-squared down, p-value up. So they are inversely related. The chi-squared being smaller would have us achieving a larger p-value over here. So the p-value now would be larger because the p-value is area to the right. Just different levels of learning this. Since chi-squared is up bigger, the p-value gets smaller. They understood exactly. Great job. 100 points in the chat. And so that's kind of the basics of it and a little more in depth on it. And we could mathematically show it over here. Did I lose it? Where'd my chi-squared go? What is going on with the world today? And so we go over here and we do this and we go to 8. And we had a hypothetical 9. And so there's the p-value and I'll disappear. But larger chi-squared goes to exactly Autumn. Great job, Autumn, right there. High p-value, fail to reject the null, right? Yep. When the p-value is high, in our first example, we would have failed to reject the null. We would not have evidence for the alternative. And when the p-value is lower than that, there we go. There we go. Low enough p-value, reject the null, evidence for the alternative. Great job right there. And definitely check out yesterday's video. We went a lot in depth. At a t of 0, we would have a p-value of 0.5 for the greater than test. At a t of 0. So how does the t-curve look? What do people think on this one? This is a pretty hard one right here. It's hard, but if you know it, it's not too bad. So at a t of 0, no degrees of freedom needed. T-curve is symmetric around 0. Hint for that. At a t of 0, what do people think on this one? Like 25%? Something like that? 25%-ish? At a t of 0... Yes, wider tails, exactly. The T is wider tails. Mr. T comes in, smashes it down, says, I pay the fool. And it's a wider distribution. Careful. I'm asking some tricky questions here. So what Olivia is talking about is the difference between the T and the normal. So when we talk about the T distribution, it's basically the normal. Because the normal looks like this, and the T looks like this. If the T has very little degrees of freedom and has these wider tails, it's all smashed down. But I think people are looking at the graphic now and seeing the answer. So how would you explain to me, if you had a T of 0, how could you do the greater than test? So what would be the greater than test? What would we do to this curve if we found a T of 0 and did a greater than test? So if we had a T of 0, say, go to here and do this, Brian. What would we do if we had a T of 0? If we had a T of 0, what would we do when we do a greater than test? Like we're testing just the mean is equal to 5. The alternative, the mean is greater than 5. And we get a T of 0. I think I know Carol's going with this. Yep. Well, so if the T was equal to 0... Like when we run the test, we get a T of 0. Exactly. So now we're going to go to 0 and we're going to shade to the right. How much of that curve did I shade? So we go to 0 and we shade to the right. We go to the test statistic and shade to the right. Since the curve is symmetric, this would be 50%. I don't think this is on the test, but I really like it. This is a true statement. And good, there was a question/answer. Robert, if we did so Robert would be correct if we did what? So Robert would be correct. Explain, Robert, great answer right there. We'll throw some points in the chat. Robert is correct if we do what? Robert, you are correct in your statement if we do what? So now, if we did, let's change it. If we do what? Awesome. Yeah, that's why I always love graphing it out so people can see. The does not equals test. Yep. So we did the does not equals test. Now the p-value, as Robert said, is equal to 1 because it's double the smallest. Technically, both are tied for the smallest. So now the p-value is equal to 1 for the does not equals test, which is saying the two-tailed test. Great job right there, John. Yep. Does not equal two-tailed test, which double the smallest, which they're tied. So
It doesn't matter.
I just love that sound effect. So larger alpha makes the test more powerful. Would a larger alpha make the test more powerful? We could go back to our notes from earlier. Our notes from earlier have some really great hints on this. We did a lot of reviewing tonight. Will a larger alpha make the test more powerful? Very true. Check out the earlier portion in the video. I guess I might not go into too much great detail, but we went over the 3 things that impact power being sample size, effect size, and alpha. Increasing alpha makes the test more powerful. These 3 things right here, the alpha, the effect size, and sample size, are directly related to power. If you decrease them, they decrease power. If you increase them, we could just literally flip these, but if we were to be increasing these, then that would mean we increase this. It is directly related, the power is directly related, but the beta is inversely related. So by increasing these, we would increase power, but by decreasing these, we decrease power. So that is a true statement along with the other values right there. Another true statement. Check previous parts of video. Really good review of that earlier. When the p-value is small, this means the null is not true. Thoughts on this? Lots of good stuff right here, and I can maybe help out, especially when the p-value is small, that means the null is not true. Thoughts? We just played that one. When the p-value is small, it means the null is not true. Where am I? I might not love this as a question. Explain to me. Like, what do we like to say? So when we reject the null, does that mean the null is not true? Because think about this. We could always make a what? I do like the question now that I just thought of this. When we reject the null, that doesn't mean the null is not true, because we can always make a what? Good follow-up question. We could always make a what? So when we reject the null, even when the low p-value is low, we could always make a what? And you're right there, Kayla. So which one? Good review of those topics. Doesn't mean the null is not true. Which error? Type 1. Because in type 1 error, the null is true and we reject it. So when the p-value is low, it doesn't mean the null is not true. It just means we have evidence to reject the null. So I do actually really like this question now that I thought of it. Mary, I am coming up with these on the fly, but no, this is very false. We have evidence the null is not true. So it doesn't mean the null is not true. We have evidence the null is not true. We could make a type 1 error. So it is possible when the p-value is small that the null is true. Really great question, reviewing errors. Tricky question, right? So what are the only phrases, like what are the good words? Good words are reject / not reject, or we should say fail to reject. Bad words, are prove and accept. These do not, if these words are on the test and anything is counted right with them, I will probably go in and start recorrecting the test. We don't like to have things to change on our test. But the good words on the test are like reject, fail to reject the null. Put cause in there. I'll throw some points for someone putting cause. How dare you put cause in my chat? Cause is a bad word too. Or will. We can talk about will in 320. But like this will do this will increase by this causes this, we accept this, we proved this. No, another good word is evidence. So, you reject the null, you have evidence for the alternative. You fail to reject the null, you don't have evidence for the alternative. So the good words are there, and the bad words, don't you be putting these cuss words in my chat. Don't you dare. But good review question right here, and literally these words are just ones you don't want to see on the test. Those wordy dirties on those tests and stats. Love it. The chi-square test of independence needs 10 expected cell counts. Condition 1! Moxie, so nice. Probable is good. Yeah, probable is good too. Possible, probable, p-value, all that good stuff. So the chi-square test of independence needs 10. Great job, Demetrius. And you're right. Why? chi-squared dependence needs 5 expected cell counts. The success, can't spell it. No one can spell it. See, can't spell it. Needs 5, 10. Wow, my brain broke. So the chi-square test of independence needs 5 expected cell counts. The success failure condition needs 10. How do we find expected cell counts? Let's go over here to this output and let's find an expected cell count. Can you... Ooh, it's too big of a table. Too big of a table. Let's go here to nice and easy. Can you find... Ooh, interesting. Can you find the expected amount of males we would expect to be in Greek life? Now you can't. Can you, right here, find the expected amount of males we would expect to be in Greek life? So take a moment. Find for me how many males we expect to be in Greek life. And that is the formula. That is the formula. Take a moment and see if you can solve it. Expected males in Greek life. That is the formula. We get to this test question. We're like, 3 points. Is it one? Ooh, that's the count. I think you have the count there, John. So we observe. Don't worry, John. John, great answer right there. Don't worry. That's the count. So that's the observed. I think Sherry's got it. 126. So remember, row total times column total over grand total. This is on the formula sheet. Equals the expected count. Now, once we get the expected counts, and we love to do this here, once we get our expected counts, what do you think we're going to solve for next? What do you think Brian can test you on your knowledge of next? There's the answer people are finding in the chat. Once again, it's the row total times the column total over the grand total. It zeroes in on it. What do you think we can solve for next? Like, mathematically, we can get what next? So we'll do it for the same cell. Sure. We love our Word documents. Cell chi-squared, Demetrius. Amazing job, Demetrius. So what is the cell chi-squared here? The cell chi-squared is the observed minus the expected squared over the expected, and there'll be 4 of them. So what is the cell chi-squared? Good. This is like a speed run of chi-squared right here. What is the cell chi-squared? So put it in the chat, like solve it. You're practicing this. If you can do this, you know it. The observed is going to be, let me highlight. Observed is going to be this. Expected is going to be this. Everyone's going to be plugging in these numbers into the formula, and that'll solve for it. So just plug in the observed is the count. The expected is, and I want to make sure people see it. It goes in this order. It gives you a key right here for what we're talking about. And so what are we going to solve? People go ahead and solve this. See if you can get it. This is the practice. The more you practice, the better you are for the test. Looks accurate. I think it's bigger than that, Olivia. Double check. I'm trying to run it in my head. It's 25 times 25 over 26 times 26. Yeah, 26 times 26 over... Yeah, it's 26 times 26 over 126. Oh, you forgot to square it. Yeah, that's why. Is it 5 point... Wow, great job, everyone. Yeah, there we go. So it is 5.267. People are confirming the answer right there. And make sure to just plug in the numbers. I'll show it here so you can watch. 101, that is the observed, minus the expected. And there's the expected. Square this, and then divide by the... I feel like I'm getting a bigger number. No, it's got the same number. I can't do math in my head today. So double check all your mathematics. Make sure to solve it. And great job, everyone, doing the solves right there. Just double check when you do it. Easy to misenter stuff in calculators. So that is the cell chi-squared. And we put it over here. And so we can see that. Now, what are we going to do to all these cell chi-squares right here? Like, what are we going to do to 2.3 and 4 and 3 and 5? So that's like 4, 5, 9, 12, and 14. What am I doing to all these right here? What am I doing to all these cell chi-squareds? All the cell chi-squareds get whatted to get the Pearson chi-squared test statistic. You sum them up. And I said about 14, and there it is. 14. And that's when we go to the chi-squared with 1 degree of freedom, because it's a 2 by 2, and we graph it, and we get the answer. Great job, Tara, right there. And hello to Tara's cat. Great job right there. Let's watching the streams. Excellent stuff. I've noticed that a lot of people have their animals watching our streams. Is the cat tuning in tonight, Tara? I believe it's Tara's cat that watches the streams. But I always like seeing that. I've thought about bringing Jolly over here. I don't know how chilly it would be in my arms if I brought him all the way over here. I don't know. If something happened, I'd feel so bad. And if he got out of my hands here, and he'd be in wire heaven. We have 2 bunnies, if you didn't know, and he got into this room one time, maybe twice. Jazzy says hi. She's that's awesome. Hills on the lap. Oh, Matthew, that's awesome too. Hello to Matthew's dog right there. So and Jolly and Morty, you being okay out there? You being chill? We can pick alpha. Can we pick our alpha? Some points for everyone's animals in the chat. Oh, that's awesome. That's good to hear. Taz says hello. Oh, do kids count? They're the most strenuous type of animals. My paramedic is not at all. Hello to Sherry's paramedic. We can pick alpha. This is a true statement. So this is whatever you want it to be. I am going to make executive decisions. That's the 3rd time. Let's see. There we go. Gonna go way. Good. Yeah, fix that. 2 quantitative variables should be a 2-sample t-test. Great job right there. 2 quantitative variables should be a 2-sample t-test. So when we do 2 quantitative variables, what do you think? 2 quantitative variables should be a 2-sample t-test. Good tools and techniques review. False. So this is false. Why? What is it? What is it, man? Surely Sherry knows. What is it, man? Old stuff right there. Regression. Yep. Regression or correlation. You need a quantitative Y and a 2-level categorical X for 2-sample t-test. Yep. That's false. In a 2-sample t-test, the values of the sample size n can be different. True or false right here? A little bit easier right now. What do you think? I'll let you answer. Yep. Great job, Kayla, right there on the answer. Excellent work. This is very true. Mm-hmm. It's just how much you collect on each. You don't have to have the same sample size for each group. You can give 100 people Dunkin' Donuts and 120 people Starbucks.
It doesn't matter.
So this is very true right here. So you can give, like we can collect 100 samples for one group, 120 for another. Then we take the mean of those groups. The 1 sample T has n-1 degrees of freedom. The 1 sample T, true also. So we did a question earlier where we figured out the sample size from it. And where was that output? We lost it. It was over here. Yep. So we were able to figure out the degrees of freedom or the sample size because the degrees of freedom are 1 minus n-1. So you see this right here. Now, the 2 sample T, which we can do, we could compare fit y by x and look at, this is pretty interesting right here. So why is this a 2 sample T right here? Why is this a 2 sample T? And I'm interested to see how this turns out. It might be one of our last tests tonight. Why is this a 2 sample? Well, the way we collected the variable explains it too. So we're going to compare right here the amount on average that males spend versus the amount on average that females spend. And so here we go. Let's go here to t-test. Oh, and that's a pretty big difference. But if I told you that, what does this difference mean right here? Interpret what that difference means. We'll do a little confidence interval interpretation right here. Kind of goes to the last question too. You're right, it's cat with a quant. And we set it up such as a 2-level quant cat right here. And so what does that difference mean that we saw in our data? I'll give you hints by doing an analysis we don't do. And you can see down here what's going on. What does this difference right here mean? And you can see the answer down here. Mm-hmm. And so, once again, the second mean is higher by $100 more, 100.68. And you're like, females spend $100 more on their pets than males. And you know what's even better about this? Oh, wait, yeah. It's so close. It's close. It's close. So what's interesting here is we almost got a really nice T-score. Because if you're at a T-score of 1, it'd be about 68, and outside would be about 32, but it's a little bit bigger T than that. But notice right here that difference of 1. But the thing is, Mackenzie, I know, right? It's like, well, females are so nice to their pets. But what? That. What? What's going on here? What's not going on? But the difference of $100, you're like, $100? That's so much. But it could just be by what? There is a lot, and there's a lot of variation. Look at all that. Someone's saying they spend 20,000. This male right here is like, I dropped 20K on my horses. He's got salamanders. That's what he's got. I don't know. The difference right here that we observed is very likely by random chance. It's very great job, Alexander, right there. It's highly likely that these differences we see are likely due to random chance. Even though we see a difference of 100, we don't have enough of a difference to conclude, or the variation, as Cherry's kind of pointing out too. There's enough variation within the groups that it seems like maybe it's just like there is no difference. We don't have evidence of a true difference. There is a difference of 100 we observed, but that's not actually large enough, which is kind of crazy to think. But especially with people buying like horses or whatever they're spending their money on, it's got to be gerbils, right? I mean, I don't know. What do you spend $20,000 on if it's not rabbits? Rabbits, that's what is really expensive. But random because of the high p-value, it's likely that these differences are due to random chance. So this is probably one of the hardest intervals to interpret. A great place to kind of finish off with this. I am 95% confident the true difference between what males and females spend on their pets is contained in the interval up to males spending $84.96 more on average. Toads, to females spending $286.32 more on average. Last question of the night. What is the margin of error of this interval? And I'm doing it in my head. Might do another one tomorrow. Who knows? I'll be answering more emails here in a moment. So trying to keep up with everything. But what is the margin of error of this interval? I think there's an easier way to get it. I've got an estimate in my head. We'll try. I don't think it's that. Michelle, good guess right there. I think Kayla got it down to the decimal. It's about what I signed there. I went 1. And then it rounds to what I said. I think people are doing it properly, but there's a trick way to get it. The margin of error is half the length of the interval, right? So what if you went to the middle of the interval at 100.68 and found how far that is away from 286.32? Did anyone do it that way? That's awesome, Robert. We're here to teach you new things. I like doing some like different ways of solving stuff sometimes, because if you're at the middle of the interval, you could just go to one side of it. So probably a quicker way is to say, well, if I'm at the middle, then let me just look the distance away the other number is. So great job right there. If you solved it this way, that's kind of a different way to solve. CC, great. I'm throwing everyone 100 points for here at the end. Yep, and then you can divide by 2. Yep. Yeah, it's like, and that's what we try to do. If you learn something like 3 or 4 ways, which we're not here, you just have to know one way, and that's the thing. You learn 4 ways. If you know one way on the test, you're good. And the more you understand it conceptually, the less you rely on a formula, and you say, well, I'm just figuring out how far these numbers are apart. It's plus or minus, so if you feel like you get something wrong on the test, let me know, because technically, Rock,
It doesn't matter.
he knows what's up. Let's do something we don't usually do. Let's do a little fun right here. So the last one was true. Let's show that, because we got to show that. The last one was true. The 2-sample T is a complicated formula. Oh my gosh. The 2-sample T is a complicated formula is also true. We would use applets or stuff like this for it. You can see the 2-sample T. That is the pooled T. We do not do the pooled T. I was just showing it so we could see the numbers. The 2-sample T has the complicated degrees of freedom. The pooled T, I won't mention it, but don't remember that. That's not, we don't do the pooled T. No pooled T here. No pooled T. 2-sample T, assuming unequal variances. No pooled T. But let's head over here. No, I'm not going to do that. I was going to do the boss. I don't want to do that. I want to do a scary outro. Let's do a nice and happy outro, like our usual. We did this for the last day of class, so let's... Am I off the screen on it currently? I'm like, oh my god. Let's go over here. Where am I? Oh, I'm on the screen. Yeah! Everybody, You know, you might think I'm the hacker man, but you are hacker man, hacker woman, hacker person. You got this, everyone. For now, we'll be back. Probably stream other times. And I don't think it's gonna. I'll get it. No, I'll check. Yeah, I'll check the Discord chat too. I'll be checking it out, everybody. But keep it up. I'm gonna go back to the future here. So you got it. UT's looking great. I'll see everyone later. Hacker man out. Woo! Going off the screen here. Wait, a little more air. Yeah, there we go. We're back. We're gone. Bye, everybody. Bye for now. Woo!